Okay, welcome everybody to week 13? 12? I don't know. Day 2. We're not going to do a whole lot today because your RPG assignment is due on Friday, and I actually want to give you just lots of lab time to work on it where I'm going to be here and I can just help you out. In the previous class, I lectured for about 10 minutes, so I'm going to do the same today. I discovered, I got a question from a student, let's put it that way. And the question was, how do you sort a vector of smart pointers, right? And so the answer is it's annoying, right? Like C++'s implementation of inheritance just isn't as easy to use as Java's. That's just a fact. In Java, you can just make a vector of actors. Like here we got our class hierarchy. We got an actor. Hero inherits from actor. Monster inherits from actor. And you can add details, but whatever. In Java, you just make a vector of actors and then just set individual actors to be heroes or monsters, and everything just kind of works because everything in Java is a pointer, right? In C++, you have value types, which would be just a plain boring actor, but those can't. Inheritance doesn't work with value types, right? It only works with reference types, either a pointer or a reference. And so that's why you need to go through this extra step of making a vector of shared pointers of actors. Zybooks has you using raw pointers, and using raw pointers in a vector is just asking for trouble. It is just not good. So this is the Zybooks way of doing it. So you make a vector of actor pointers, and then you push back, you new each thing in it, and now who knows if that's going to get freed properly. Remember, every new needs a delete, and so it's kind of up to you that when the vector is going to go away. If you're really super cool advanced, maybe you wrap this in a class that has a constructor that does this and a destructor that does this, but you still can't guarantee that you won't leak memory. And the reason why you can't guarantee that you won't leak memory is because somebody could always do this. They could always say vec3.popback, and that is going to delete the pointer to this monster here with a speed of 100, but it doesn't free the memory, it just deletes the pointer to the memory. Do not confuse the pointing finger for the moon, or you will miss out on all of that heavenly glory. So if we compile this with address sanitizer on, you will see that we are in fact leaking one object of memory. Every time you call pop back, you have to delete it first, right? You'd have to say delete vec3.back, that, and just hope that the person who is popping off the vector remembers that they are responsible for deleting it as well. Good luck. Good luck making sure this always happens. Okay. And you also need this, where when the vector goes away, if you know where the vector goes away, then you say while there's stuff left in the vector, delete the last element and pop it. And this is super garbage. And that's why there's an unhappy face here. So the better way of doing it is what I showed you earlier, which is to use a shared pointer, and then when you pop things off, they just automatically free themselves. Yay! And when the vector goes away, all of them get deleted, and all of them, clean up after themselves. So it is just the superior data structure here. And unfortunately, Zybooks teaches you this way, which is the 1980s way of doing it. Okay. Well, they didn't have vectors back then. 1990s, ANSI 98, I think vector was added, something like that. STL existed before then, but whatever. This is how you used to it, and it sucks. So don't. Now, the problem is though, when you have a vector of shared pointers, then in order for you to sort a vector of shared pointers, you have to have a custom sort function, or you can use something called a functor, or I don't know, there's probably other ways of doing it too. But this is how I did it. So I made you could probably use a lambda if you're only doing it once. So I just made a custom function, and I called it my sort, and it takes two const reference shared pointers of actor type, and I just call them A and B. I could have called them LHS and RHS, whatever. And I'm just sorting them based on speed. So it's going to go from least to greatest, lowest speed to greatest speed. Okay. And notice I'm using the arrow operator here, not dot, because these are pointers. And so you pass in the shared pointer by const reference, and then you return true and false using this. And that allows you to sort the vector like that. So you say sort from the beginning to the end of all these smart pointers of type actor, and call my sort. And it'll sort them based on speed. And then it doesn't matter if you have a mix of actors and heroes and monsters or whatever, as long as the actor class has the speed attribute, then it can sort them just fine. Okay? So that's how I recommend doing it. I was kind of poking around last night, trying to see if, like, because there's all this modern, C++ stuff. My CSci 45 students are implementing things that are, like, literally brand new in the language. Compiler support has been sort of trickling out for a lot of these things, and in fact, on the Raspberry Pi, the compilers don't support the thing that I had them benchmarking, so they had to use their own machines, or Visual Studio does support it, or on the main server here, where the compiler here supports it, but the compiler on the server for 45, there is no compiler that supports the feature that we were looking at. So, point is that C++ is always moving, and so I was like, all right, let's see if they've made it easier to do sorting a vector of using inheritance, because it's kind of garbage, right? And there's this thing called reference wrappers, and at first it looks kind of like what it's Java, right? It kind of has that feel at first. So rather than making a shared pointer to actor, we have reference wrappers to actor, and what that does is you can pass in H, or you can pass in M, and it automatically takes a reference to it, and then you could like down here we got, this is vector 2, so we could add vector 2, we can add monster 2 to it, and down here we can add hero and monster 1, and it seems to work, and it seems nice because you're just pushing hero, you're pushing the monster in, and you can say for every variable in vector 2, see it out, and I've got a little, I got a thing up here, and it seems to just work. I mean, it seems to work just like it's now a value type, like it's just like a regular variable, but it doesn't. And there's two places, one that's deadly, one which is annoying. First of all, this doesn't work. Even though I have a member function here that tells us how to sort actors by speed, it doesn't work. It'll work if you make it a global function. If I were to do this and make it a global function rather than a member function, then it works. But if it's a member function, it doesn't work. And it can't be constant. Thank you. And it just seems like, okay, all right, that's a cool solution. Here's the thing, though. It's actually really bad because it doesn't help manage your memory, right? Shared pointers will help manage your memory. If you pop back off this vector here, it'll automatically free the memory it's pointing at. What a reference wrapper does is it just takes a pointer to H and it takes a pointer to M. It doesn't actually store anything itself. And so it looks like you're putting like M2 into this vector here, but you're not. You're putting a pointer to it in there. And so what happens right here is M2 goes away right here. So I made monster 2 right here, and I added it to the vector of reference wrappers, and then it gets deleted. And so this here is now a pointer to a stack allocated variable that doesn't exist anymore. And if we run this, you will see it get very, very mad. Right? You use the stack after scope. In other words, after it went out of scope, you're using it. And address sanitizer gets mad at you. So long story short is this isn't the solution that you were looking for, unfortunately. So basically the best option is this, because reference wrapper doesn't help you with the memory management problem, which is why we do vectors in the first place. We do vectors so that it manages our memory for us. It grows, it shrinks, it frees, it news, it does all that stuff under the hood. You don't have to worry about it. It just takes care of it for you. And shared pointers also, they go hand in hand with vectors. Smart pointers and vectors go hand in hand, like peanut butter and chocolate. They're really nice. You can't memory leak. You can't double free. You can't, all those use after free. All those bugs just kind of go away. You've got one tricky bit here that you could maybe worry about, which is that these pointers could be null. References can't be null. The references must point at things. But because it's not managing the memory itself, you can have dangling references, which are literally the worst thing ever. Because at least with pointers, you know that pointer could be null, and you can oftentimes check for it if you're worried about it. References are never supposed to point at bad memory, and they're never supposed to, have that issue. And yet it's that easy to do it. So, long story short, don't write this code. Just do the code that I posted on the chat, and you'll be fine. You want to make a linked list of shared pointers? Okay, sure, let's do that. And yeah, don't do it the Zybooks way either. So we got all this stuff. Don't need you anymore. Don't need you anymore. Need CMath? I don't think so. Numeric? I don't think so. Functional? No. Get rid of vector even. C time. Okay, let's make this as short as possible. Alright, so just delete all that old code. We don't care. So I'm going to make a list of actors. Okay? And the trouble with this is that this is a value type. This is just a regular variable. And if you try putting a hero into this, if you have a hero h, it's initialized to the speed of 120. If you say li.push back h, what happens to our hero? If you just have a regular variable of type actor, what happens if you put a hero into a variable of type actor? It's not a reference type, it's not a pointer type, it's a regular variable. What happens to our brave and noble hero? It will get sliced. Yeah, in this case, nothing happens because heroes literally, I was just too lazy to put additional stuff in there, but yeah, it would slice it. Just pretend that there's stuff inside of hero and monster, right? It would slice it. So can't do it. And so we have to make sure it is a, not a smart, it is a shared pointer of type actor. Actor. Yep. And then it won't slice if we do that. Now, you can actually make it a little more compact than I showed you by just doing make shared and do that. Make shared type of hero. That. And so that will make a hero with a speed of 120. I don't need you either. And then we can make a actor of speed 20, and we can make a monster of speed 100. And then we can say for const auto reference, make sure it's reference. If you did this as just an actor, it would be bad. Every time you work with an inheritance, it's got to be a reference or it's got to be a pointer. So for every actor in the list, see out that actor. And right, so we need to have because it's not, because this is a pointer type, so we will dereference the pointer. Right? All this stuff is just like so aggravating. There's just like always one extra step you have to do in order to get inheritance working, right? And so we have to dereference the pointer, right? Because what we're doing here, this is the problem with auto, is that it hides the type, which sometimes you need to know. So shared pointer type actor. There. So see, it's a shared pointer we're getting. We're not getting an actor, we're getting a shared pointer of type actor. So we do that. And no matching function call for construct. Yeah, fine. We'll add a constructor. Yeah, whatever. Add a constructor. And so there we go. So we got a linked list of shared pointers of actors there. And if you want to sort it, you could say list.sort. And I think you might have to pass in my sort. See if that works. I don't use linked list sorts very often. Let's print it out again. So we print it out originally, print it out again. There you go. So it's sorted the linked list by speed. Okay. So does that answer your question, Holman, or do you want to? Are you asking specifically about the circular linked list class for bridges? Because my advice is you stick one person on bridges duty, okay, and have one person making, I don't know, the classes and stuff, and one person making the map in the game. You're on bridges duty, okay. So you're thinking about omitting the make shared. I don't know, maybe you could. I don't know. Because all you technically need to, like, you probably could get away with slicing. Because for the circular linked list, all you need to print is the name and the speed, and that could be both beyond the actor. So if you just want to slice the people down to size, you probably could get away with that. What you're going to do if you're on bridges duty is you're going to look at the source code that I've given you, not hash table. I signed it too long ago. Circular DLL list here, and so the example bridges code that I gave you is a fully functioning and operational Death Star, right? It's got a main and everything. All you need to do is punch your bridges code in there, API key and user ID and project number, and it'll render it, right? But I'm not going to give you credit if you just render it with the students, right? Because that defeats the entire purpose. Like, I understand you know how to compile and run code. That's not worth a letter grade. What you're going to have to do is make a circular doubly linked list using not student info, but actor, okay? And if you want to make it just actor, I think you could probably get away with it, because if you just slice it, all you really need is the name and the speed, and I probably wouldn't notice. If you wanted to be more precise, you would do it with what I just showed you. You make a circular doubly linked list of shared pointers of actors, and then it'll do the polymorphism correctly. So yeah, take this code, switch it out, and with an actor, include your actor header file up here. So rather than using student info, you're going to include actor. You can probably delete the student info header. I would. You should have no students anywhere near the monsters, right? It's considered it's against ed code, to pit students against monsters. Okay, so so what it's doing, it's making an array of pointers of circular linked DL elements. So this is an array of pointers. And then after they knew all of these things, they go through the array, and that's kind of hilarious that they have 5 here when it just happens to be 5 here. Like that makes me very, very nervous to see that. Right? It's not const either. This should probably be a const, and it should probably be up here, right? So that if you omit the size of an array when you're initializing like that, it'll figure out its size. But what I think you should do is probably deduce the size of the array from that, right? Which you can do, but or just use a vector. I don't know, or just not use an array of pointers at all. It's not necessary. All of this stuff here is actually not necessary. Okay, so anyway, what they do is they have an array of pointers, and then they just kind of just link them all together, right? So if it's element 0, it sets head. Otherwise, it inserts at the front of head, and the insert front function, which works, just does all the pointer math for you, so you don't even need to figure all that stuff out. Just have it be a circular DL element of actors instead of students, and everything should work. And then this code here is like just showing you how you can set colors and thicknesses and things like that, which you don't need to do. All you need to do for the assignment is just render the initiative tracker, right? So sort it by speed, and then just have a circular linked list showing the turn order as you go around the table, like in poker, right? And that's it. And then you call visualize. And then you're just going to integrate this into your existing project. So when combat breaks out, you get all of the heroes. You have to have multiple heroes in combat. You have to have multiple monsters in combat. integrate them together in a circular DL list of actors, and then visualize it, and print to the screen. Here's your thing. You can open that up, and you can see the turn order for your combat. It's a little bit goofy, but whatever. It's good for you. Okay. Does the amount of monsters need to be the same as the amount of heroes? No. How many monsters do you have to have? At least 2. It's same for heroes. Okay. You have to have multiple heroes and monsters. If you want to randomize the number of monsters from 2 to 5, then basically what you're going to do is look at the code that exists, which shows you how to insert into a circular, linked list, and just do it. I wouldn't do what they have here. What they have here is they just hard coded five students, right? I wouldn't do it that way at all. I would just if you have a vector of the heroes or whatever, just iterate over that instead. Gonna make a special cheat code for an OP class. Feel the kern. Yeah. How do we call the list in main with in curses? So all of this code can be put into your regular main, right? Wherever your combat function is, all of this code, like if you just think about it, right? It creates a new bridges object. Make sure you delete it, by the way, or you're gonna memory leak. All this could just be within whatever your combat code is, right? You do that rather than hard coding all this stuff. You just read all of the heroes, read all of the monsters, and add them to the circular linked list. And then when you're done, you need to delete all of them because this is leaking memory over and over again. You don't need to do any of this stuff. Yeah, basically just set the data structure to be the head, call visualize. That will print out a URL, and you just do that in the middle of your combat routine. Okay. So you can't initialize head equal to null pointer. Yeah, if it's a smart pointer, you can still set it to null pointer. It'll work. So shared pointer of type actor equals null pointer. It's perfectly valid. If you just like that, see? So I have a shared pointer. Make sure there's no actual star there or something. A lot of students will do this, right? It's a pointer to a unique pointer. No, don't do that. Yeah, so you just do a shared pointer equals null, and that's fine. How would I set combat to only fight 3 monsters and not the whole list? I don't know. Basically, when you walk over a monster square, what I would do is just generate 2 to 5 monsters randomly. Put them into a new vector of like Team B, Team A. Team A is the heroes, Team B is the monsters. I don't know. However you want to do it. Yep. Or just select, from the vector class, select the 3 nearest monsters. Whatever. However you want to do it. Each M on the map could represent multiple monsters, for example, if that makes it easier for you. So you walk over a goblin square and 3 goblins appear. Okay. Conversion from null pointer to bridges data structure seal life requested. Circular DLL element. So it's like a pointer to a pointer. Maybe just have your circular DL element just be pointing at a life form. No, I don't know. Then that wouldn't work. If you have a vector of actors, how do you know if it is a monster or a hero? Great question. Welcome to Why Inheritance Sucks. Part 2. Yeah, a lot of times you actually want to know, hey, is that thing a hero or a monster? And so the whole point of doing inheritance is that you don't have to constantly do if statements. Be like, if it's a hero, do this. If it's a monster, do this. But sometimes you actually just want to know. And so it's very common to have something called a tag. right? And so in this case, if there's just hero monster, something like that, right? Or, you know, string class name. And then in here, you know, in your hero constructor, just going to call the actor constructor. You do something like that, right? And so you end up a lot of times spending so much time trying to get the type system to work. A way around having to do a tag like this is you could do like a string ID kind of thing, return actor, something like that, and then rather than having a class name, you can just strong, strong, strong. You can do something like that, and then you don't have to do a tag, right? But it's very common to have a tag, which is, you know, it because C++ has all of that type information, and you would think it'd be like pretty easy to get at it. Like, hey, who am I? Am I actually a hero or am I actually a monster? And C++ actually does not make it easy for you to do that. And so you can either use inheritance, that's probably a little bit more proper, call ID and it tells you who they are. And so if you hit somebody, you can call ID on them and be like, hey, if I hit a monster, do double damage or something. If I hit a flame Pokemon with a water attack, it does double damage or something. Yeah. Explosion. I love C++ error messages, don't you? Construct add. Right. Now, they could have just said, hey, you need a constructor. Instead, that's what you get, because C++. And file included from all this stuff, user include C++ 11 bits alloc traits and instantiation of const expr void std allocator traits bop 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 required from error no matching function for call construct at hero pointer reference int. And, you know, fortunately I know how to read C++ error messages, but they do not make it easy on you, let me tell you. C++ error messages are kind of garbage. So, yeah, and so you do that, and then let's just hit that compile. After all that talking, good. Okay, and then you can say, okay, it's hero, actor, and monster. These sorted actor, monster, hero. So that's how I would do it. And then there are ways, I think, of getting at the RTTI information, but at the same time, you can actually compile C++ in such a way that it's not available. And so I just personally do something like this. So you just, if you need to know the type of something, you can get it, because by default, like, you can't, and it's or at least it's hard to get the type of something. It's not very straightforward. This is a pretty straightforward way. So just every time you override a class, you just override the ID thing, and yeah, so I do it. Okay, so I'm going to give you the rest of the class to work on the homework assignment. hope we all learned something today. Yep. And if you need any help, just message me. Mincorelli is out through. He's online right now, so Mincorelli, you want to say any words to the students? I like it. Can we get an extension? No, no. It's due on Friday. You can use your Bridges class for the visualization to implement your own linked list class. Absolutely. So if you want, I can extend it out to like midnight on Friday, if that works for you. Give you a little more time. But there is going to be an extra credit opportunity over spring break. So basically 10 points are on the table for any missing assignments you have. It'll be doing HackerRank, the BST section on HackerRank, all the easy and mediums. I haven't actually looked at it yet. Let me just before I tell you that, let me actually take a look at HackerRank and just make sure that it's. Where's my thing at? Where's my thing at? There it is. There it is. Okay. You have 3 monitors. It's hard to find where your new windows are. Okay. C++. Inheritance. Maybe we could have you do inheritance. Yeah, I might put together just a list of questions. World data structures. Let's see what we got here. Trees. Easy. Huffman decoding is medium. I wouldn't necessarily say it was medium. Easy. Is this a binary tree? Search tree. Jenny's subtrees, tree coordinates, array pairs, self-balancing trees. Yeah, let me take a look at these. And then, there's a lot of them, huh? Alright, let's try trees. Just sort by that. Easy. 3, 6, 7, 8. Yeah. Yeah, I'll put something together, and it'll basically be worth making up 10 points of missed either individual or group assignments. Okay. But yeah, I do want the RPG done by Friday, and I can give you till midnight at Friday, but no later than that. Okay. Do you think we can give them a choice for that extra credit, like one more last chance or the HackerRank assignment? I don't know what that means. Can you reopen the zyBooks? This is the first zyBooks. Yeah, go ahead and just redo it and let me know when you do it. Get a chance to turn in any old homework assignment? Just one. I mean, we've kind of given the solutions to a number of the homework, so it's kind of can't do it. So basically, we'll just do the HackerRank. Okay. Because you just pull up my lectures where I show the answer. Like there you go. Okay. All right. So yeah, that's it. Go ahead and work. Ask any questions you want to ask, and I'm going to put together this extra credit assignment for you, and it'll be due at the end of spring break. And if you want to have fun on spring break and not do it, it's up to you. It's just extra credit. All right. Peace out, you guys.